Hello. Welcome to this lesson where we're going to look at factorizing algebraic expressions. Now we're going to go back to something that we learnt last lesson, which was the distributive property, or the distributive law, which is this thing here. We used it last lesson to expand our brackets. So we had a term like this one and we wanted to get here. This lesson we're looking at factorizing. So we're going back the other way. We're trying to get it in this form. Both of them are important for different types of questions, and they're very key fundamental concepts for algebra. So here, this here is factorized. This one here, and this here is expanded. So last lesson we were expanding the brackets. We were going from here to the expanded form. This lesson we're factorizing, so we're actually going back to the factorized form. So we're trying to get it to look something like that. This is something that's very important to remember, so make sure you've written that down, and we're going to go on to some examples. So here we've got some examples and again some questions, and they're quite similar. So for these we need to factorize, we need to go back here. And you may or may not have noticed that this here is actually the highest common factor, or we can often abbreviate it as HCF. So that's the biggest number that we can take out so that the other two numbers don't have any common factors. Now the way that we can find this, if we look at the numbers and don't see it straight away, is to use a factor tree. So I'm going to make a factor tree for both of these terms here. So you've done these in the past. We have 6a and a, and I'm going to just separate our algebraic variables and our coefficient. So we got 6 and we have a. Now we want to divide 6 down and get all of its factors until we come to just prime factors. And we do that by going to 2 and to 3. Now 2 and 3 can't divide any further, so we know we've gotten to the bottom. Now a is just one term, we can't factorize it down anymore. So we look at the 12ab. So 12ab, we're going to get our 12 and then an ab. Now our 12 we can further factorize to get 6 and 2, and then we can get 2 and 3. Now our a and b we can then factorize to get a and to get b. Now when we want to find the highest common factor, we want to take each of these last points, each of these prime factors, and find out which ones are common. So I'm going to start here and I'm looking at the 2, and I'm looking for a 2 over here and I can see one. So I'm going to circle the 2 and this 2. Then I look at the 3 and again I can see a 3 over here. So I'm going to circle that. And then we have our last factor, which is an a. And again we have an a here. So I can see from this that these things are common factors to both of these numbers. So that's going to give us our highest common factor when we multiply them together. So we're going to multiply our 2, 3 and a. We just do it once, we don't include it from both piles. So we're going to get 2 times 3 times a. So this is our HCF, which is going to become 6a. Now I'm sort of running out of space here. Usually you would put the next things on another line, but I'll just put a dotted line here so you can see. So we have our highest common factor of 6a. Now it becomes a lot more easy. We want to put our highest common factor at the front, so we're going to go 6a, and then we're going to have brackets with stuff inside of them. So the way that we find out what this b and c are is we're going to divide this thing here by our highest common factor and this one by our highest common factor. So if we divide 6a by 6a, we're going to get 1. So we can leave a 1 there. If we divide 12ab by 6a, we can start with the coefficient. 12 divided by 6 is going to give us 2. So we go plus 2, so keeping this same thing here, plus 2, and then our ab divided by our common a, we're going to get b. Now, we've completely factorized that. We've gotten 6a and then 1 plus 2b. Now, we can expand this to check that we get back to the same answer. So you can go from one to the other and backwards and forth. And a good way to check that you've expanded well is to then that you factorize well is to then try to expand your answer. So I'm going to quickly do it underneath. We get 6a times 1, and we're going to get 6a. And then 6a times 2b, we're going to get 6 times 2 is 12, and then a times b is ab. And we've come back to our first answer. So we know that this is the correct factorization. Now we're going to go on. I won't draw a factor tree in this one, just for sake of time. So here we have 4t minus 12. So there's no algebraic thing common to both of them. So we know that that's not going to be in the highest common factor. Now you can work out your highest common factor just by looking at the numbers if that works for you. So you can skip this whole step here. But if this is something that helps you, make sure you do it because you want to make sure you don't miss anything. So here we have minus 4 and minus 12. And there's a minus on both of those. So we're going to take the minus into our highest common factor. Next we have 4 and 12. And I know that 12 divides by 4 3 times. So I'm going to take out the 4 because that's a common factor. Minus 4 divides by 4 and minus 12 divides by 4. Now we can start writing it. So remember our highest common factor goes out the front. So we get minus 4, and then brackets. We divide this thing by minus 4, which is going to leave us with t. We divide this one by minus 4, which is going to give us a positive 3. Now, if you're confused as to why I put a plus here, that's because we've taken our minus out the front. So if we would expand this, we can check that we've done the right thing. We go minus 4 times t gives us minus 4t. Then minus 4 times positive 3 is going to give us minus 4 times 3, which is minus 12, which is the answer that we wanted. So we've just checked our answer here. So notice if you take our minus out the front, you need to leave a plus there. Finally, the last question. Now this one is a bit more complicated. I'll draw a quick factor tree. So we're going to first divide our first term. And x squared is the same as x times x. So we can write x at x. Next we have our minus 5 and our x. So I'm going to put our minus 5 there and our x here. And that's as far down as we go because this is prime and these variables are by themselves. Now if I circle our common prime factors, we have an x and we have an x. There's no other x over here and no minus 5 over here. So that's a highest common factor of x. So if our highest common factor is x, we can put that out the front. And then we need to divide both of these by x. So we're going to get x minus 5. Now again, we can check by expanding. We're going to get x times x, which is x squared. X times minus 5, which is minus 5x, which is the first answer, which is what we want. So don't be scared by seeing squared and cubed signs. That just means that you can put down as many x's as they are of that number. So if that was x cubed, we'd put x, x, and x. Now there's 3 questions. Have a go at those, and then I'll show you the answers.